good morning, everyone, and thank you all for joining us. We will give just 2-3 more minutes for the late joiners to come in, and then we'll begin the webinar. Just so you all know, this session is going to be recorded and will be uploaded to YouTube and other social media following this session. So if anyone wants to recap or revisit the topics or even share it with other people, you can absolutely do it. So we'll take 2-3 more minutes for the late joiners to come in, and then we'll start. Thank you. Okay, so good morning, everyone, and thank you all for joining us for this very special webinar that I'm pretty excited about. So today we are going to talk about a very, I think, interesting subject. I know from experience a lot of my customers are really into SQL, and most of the core applications are running on SQL Server databases. So I think it's a great opportunity to hear and see some very amazing, very, I think, powerful capabilities that we have with everything related to how we back up, recover, and do some cool SQL magic when it comes to snapshotting and advanced snapshotting provided us by Pure Storage Technologies. So just some housekeeping before we get started. This webinar is being recorded and it will be uploaded on social media, YouTube, other platforms following the session. So you can always come and revisit the topics and even share with your friends and colleagues. And for any questions, please feel free to use the Q&A box that is available to you. We will try to answer those questions during the session. Hopefully, we'll have the time to answer all of them. So, we have here an esteemed speaker here with us today. We have Pure Storage's very own Andrew, and he will present himself shortly. So, my name is Ariel. I'm a solution architect with TerraSky. I'll be the co-host today. Gonna help out Andrew with driving this thing forward. And please, guys, if you have any questions, please make sure to put them in the chat box, in the Q&A, and we'll get back to it. So, Andrew, good morning.
Good morning. How are we doing?
We're doing amazingly, yes. So, do you want to tell us what we're going to do today?
Yes. Hi there, everyone, and welcome to this session on SQL Server Instant Recovery. So we're going to be doing a lot of demos. I'm not a PowerPoint person, so we're going to do some slides, doing an overview, and then we're going to get straight into the demos because I like to show people how this actually works and some of the really cool things that you can do with Pure Storage's snapshot technology and SQL Server.
Sounds amazing. Okay, so I think let's maybe introduce you first and foremost, and let's dive into it. I think people are excited to see what we have going on.
Yes, hello there, everyone. My name is Andrew Prusky, and as Ariel said, I'm a field solutions architect at Pure Storage, have been with Pure since September last year. But before that, I was a SQL Server DBA for around 15 years. I'm a Microsoft Data Platform MVP, have been for the past 6 years. I'm originally from Swansea in Wales, but I've been living in Dublin, Ireland for around 10 years now. And I do a whole bunch of stuff in the community here in Ireland. I run a Microsoft Data Platform conference called Data Cayley. I do an online conference that focuses on SQL Server internals called 8KB. And I'm a VMware user group leader here in Ireland as well.
Sounds like you're a busy person.
Yes, it keeps me out of trouble.
And it also sounds like you know a thing or two about SQL Server, which is perfectly fitting for our subject.
I've been around the block with SQL a little bit, yes.
All right, so please, Andrew, lead the way.
Let's get into the session.
Yes,
so,
exciting.
Today we're going to talk about SQL Server Instant Recovery. So what that basically means is snapshot technology. So what we're going to talk about today is we're going to have an overview of snapshots, basically what Pure Storage supports when it comes to snapshots. And then we're going to dive straight in and we're going to have a look at recovery of data using snapshots. Now, this could be from a data corruption, does happen, could be from some sort of application issue, or more commonly, and this has happened to me a few more times than I'd like to admit in my career, user error. So running a update or delete statement without a where clause. But we're going to have a look at how we can use snapshots to instantly recover that data instead of having to go through the whole usual process of restoring full, differential, and then transactional log backups. Then we're going to have a look at using snapshots to perform a point-in-time recovery using Pure Storage's plugin for SQL Server Management Studio. And at the end of the session, to round off, we're going to have a look at one of the cool things we can do now with SQL Server 2022, and that's seeding availability groups with snapshots, because Microsoft now supports snapshots natively within SQL Server itself with their native T-SQL snapshot backups. So we've got a lot of stuff to cover. Let's dive straight in.
Sounds amazing.
So we have two kinds of snapshots that, well, both kinds really. There are only two that Pure Storage support, and that is crash consistent and application consistent snapshots. Crash consistent snapshots are just a snapshot of volumes at a point in time. So for us as SQL Server folks, that is our data and our log volumes. Now, Pure Storage has a concept of something called a protection group, and it's just a logical entity that we can drop our volumes into And then instead of individually snapshotting the volumes, we snapshot that protection group, which basically means we get the data and log volume snapshotted at exactly the same time, which means we can then do some cool things like refresh, test, and development databases. We can recover data from data loss events, and we'll see that in a demo coming up. Or we can even ship offsite for disaster recovery purposes. But we also support application consistent snapshots. Application consistent snapshots differ from crash consistent in that the database needs to be quiesced before we take the snapshot. So IO needs to be stunned on the database. We take the snapshot and then IO resumed. Now the benefit
Andrew,
of application
isn't this a potential issue for people who have like very high load databases running with very high transaction count of concurrent streams?
Yes, that is 100% one of the caveats with application consistent snapshots is that you need to make sure that anything hitting your SQL instance can handle the IO being frozen on that database. So we're talking, you can do it out of hours, but if you don't have an hours period, then you need to make sure that the applications can 100% retry their connection coming into the database. Otherwise, yes, that's going to cause you issues there. And that's why some DBAs get a little bit nervous when you start talking to them about application consistent snapshots. That stun. Previous versions before 2022 requires going out to a VSS provider, stunning that database, coming back in. It can take some time. We're talking in the range of 100 to 200 milliseconds, which for me as a DBA personally can be way too long. But we're lucky in the fact that with SQL Server 2022 coming up, we no longer need to use that external advice. Sorry, we no longer need to use that external VSS provider. We can do it all natively within SQL Server itself, which means that the IO frozen period is a lot less in the new version of SQL. We'll see that coming up in the demos later on.
Sounds like it solves really the core issue with doing those types of snapshots traditionally.
Yes, and it also gives us a lot of faith in snapshots because Microsoft are now embracing them as a legitimate backup for SQL Server. Now, I will caveat that with, I will never say to SQL Server professionals, especially DBAs, that you can replace your backups with snapshots. You still need to be taking your fulls, your diffs, your transaction logs. But what I am saying is that in certain situations, snapshots could be more advantageous to use than the traditional full diff transaction log restores. And we'll see that coming up in certain situations. So let's let's just talk about that now.
Yeah, let's go ahead.
So one of those situations is the recovery of data with snapshots. So as I mentioned, recovering data from a data loss event, and this could be database corruption, does happen. Application issues, something's gotten released to production, and that's updated a load of data that shouldn't have been, and we need to get it back. Or more typically, more commonly, someone running an update delete statement against the table and updated a load of data or deleted it that they shouldn't have. This has happened to me in my career. And to get that data back, I mean, we could do a point in time restore of the production database itself. But if we're just getting one table's worth of data back, restoring the whole database, especially if it's a large database, it really is using a sledgehammer to put in a nail. Typically, what I've done in the past is a side-by-side restore. We use the production database's backups, restore a new database either on the same SQL instance or on a different one, and roll that database forward using the transaction log backups to just a point in time before we know when that data was either deleted or corrupted, whatever. We can then grab that data, push it back into the production database. Now, this can take some time if we get talking about a large database, multi-terabyte or even petabytes in size. And that is pushing our recovery time objective right to its limit. So in this situation, using a snapshot to get that data back would be more advantageous. What we could do is take a snapshot or retrieve a snapshot that's been taken on a schedule, offline the volume on a target instance. So we need a volume there that we're going to overwrite with our snapshot, and that volume needs to be taken offline. Clone the snapshot to the volume, so we overwrite that volume with our snapshot. Online that volume. Grab our database data and log files and attach it into the same SQL instance, or it could be a different SQL instance. And then we can retrieve our required data. Now, this is much faster than the native full diff transaction log restores because it's instantaneous. We can basically overwrite the volume instantly using our snapshot, grab our database, attach it, and then push the data back instead of running through the whole full diff transaction log backup restores, which again can take some time if that database is in the multi-terabyte, petabyte range. But enough of me talking about it. Let's actually dive straight in and let's have a look at how this works. So I've got my little lab here, and I've got a test SQL instance called ZAP SQL 01. And we have a database here called AdventureWorks 2019. This is a standard database that Microsoft published that we can use for testing purposes. And what we're going to do in this database is we're going to be a little bit dramatic. We're going to corrupt a table in that database, and then we're going to use snapshots to get that data back.
So Andrew, how are you going to corrupt this database? Let us know.
I am going to use a awful command called dbcc write page. This is a not undocumented command that's available for us in SQL Server, and I'll get into that in just a second, but I'm just going to talk about the setup here that I have so we can have a look at running our snapshots and then how we're going to get that data back. But I will definitely cover this. The caveat with that, actually, I'll get into that in a second. I'll talk about the structure of the server first. So this is the volume layout I have on my server. And for simplicity's sake in this demo, I've put both the data and log files on the E drive here. This is the volume that we're going to snapshot. And then what we're going to do is overwrite the F volume on that snapshot, on that server with a snapshot and grab our data back. So first thing we need to do is take the snapshot. So if we come into Visual Studio Code here, Pure Storage has a PowerShell module. This is available in the PowerShell gallery that you can get by just running install module Pure Storage PowerShell SDK. And then I'm going to set a load of variables. I need my flash array IP, my source volume. This is the volume that I'm going to take the snapshot of, and then the protection group that volume is in. So I'm going to set those variables.
I just want to intervene for a second for the uninitiated. A flash array is basically, just to give you an overview, short overview, it's our top of the line storage array, all flash, all NVMe, that is capable and designed to run very, very high demand workloads with low sub-millisecond latency across the board, which is very, very suiting for large databases, production environments, those sorts of workloads. And this is what we are going to be using in the background in order to enable all of those capabilities.
100% yes. So I'm going to set those variables. And now what I need to do is connect into my flash array. Now, I can't type in demos for love nor money. So what I'm going to do is import some credentials into a variable, and then I'm going to connect into my flash array. And just confirm that that's there. We're connected in. And then I can take my snapshot. That's a nice, easy command to take the snapshot. We use this little commandlet, new PFA protection group snapshot on my flash array, and then the protection group name. We hit execute. And that is the snapshot done pretty much instantly.
That was fast.
It is instantly, very fast.
Can we maybe see it on the array itself to make sure it really happened?
Let's jump into the array and have a look. So we come in here into the flash array web GUI, and we've got in protection groups, my protection group. So I'm terrible at naming things. So this is just the server name -PG for protection group. We have both volumes in there, but we only really need one. And we can see the snapshot here, 267 with both volumes in it. Now,
and it looks like the size of the snapshot is really, really low.
The size is 0 at the moment because the way we work with snapshots is that they are metadata only based. So I've taken a snapshot of that volume, and it's just pointing to the actual production data on the array. It won't get any bigger until more writes come in. And then we use something called update on write to push. We keep the blocks for the snapshot there, new data coming in goes onto the array. That's when the snapshot gets a little bit bigger. But at the moment, because there's nothing coming in completely, that snapshot is taking 0 data on the array, dedupes down incredibly well.
That sounds very efficient. when you look at large scale environments, right?
100%, yes.
By the way, anyone wants to know more in depth about how pure storage snapshotting works, we can do a separate session discussing all about them and showcasing those capabilities, because I think it's very, very unique in the storage landscape as a whole. I think snapshotting with Pure is quite a game changer. So guys, if there is a demand for it, we can definitely do a separate session discussing all the benefits and the ins and outs of Pure storage snapshots.
Yes, and that would actually be really good. And one thing I want to mention as well is I've taken a snapshot and we're going to corrupt this database. We obviously don't know when corruption is going to happen. So you can 100% schedule your snapshots. And as you can see down here, I've got these running on a daily basis, just taking one in the morning, but you can have these down to every 5 minutes if you want to, with automatic cleanup on the array as well. So we have our snapshot. Let's go and have some fun and let's corrupt this database.
Before you corrupt the database, I just want to mention a nice bit of information for all our attendees. Currently, we can handle up to 400K snapshots within a single array. So guys, if you think about it, you can really store and create a huge repository of point-in-time snapshots that will actually be very handful if you come across those use cases that we are discussing today.
So let's go and corrupt this database. So what we've got is AdventureWorks here. And in here, we have a table, the Human Resources Employee table. We're going to grab a data page there, and we're going to corrupt that data page. So I'm going to use a command called dbcc-ind. And what this basically does is just show me all the data pages in SQL assigned to that table. And we've got one here, which is page 9776 in row data. So let's use that data page. We're going to corrupt that. So coming down, we're going to use this terrible command called dbcc write page. Now, this was written by a chap called Paul Randall, who wrote dbcc checkdb, how we check our databases for corruption. And the reason dbcc write page exists is he needed a way to corrupt databases to ensure that dbcc checkdb was picking up the corruption correctly. So that's why this exists. I will say, if you run this on a production system, you are going to have a bad day. It is purely designed to corrupt your database. So what you do is you say dbcc write page, the database, the data page, and then some data that you want to overwrite. So we're just going to overwrite this page with a load of nonsense. So 3, 2, 1, and it's scarily fast. So
and that is like the easiest, fastest corruption I think I ever seen.
It's one way to ensure you're about to have a really bad time. Because, okay, we've run that. Say an application comes in or a user comes in and tries to select from that table now. And that's taking already longer. And we're getting some horrible, horrible messages here, just saying basically that we've got a severe error condition. And it can be caused by many factors. But as a DBA seeing that, I'd be a good DBA and do exactly what the error is telling me and have a look at dbcc checkdb. And I'd run checkdb against that database. So if we run that, and at this point, I'm crossing my fingers, hoping it's something like a non-clustered index corruption, because I can fix that just by rebuilding my non-clustered index. But unfortunately, we can see here, we have data page corruption. So at this point in my career, I'd be looking at running some sort of PowerShell script or some T-SQL I've already got stashed away to do a point-in-time restore of that database. But I don't need to do that anymore because we have a snapshot of this DB. So we can jump back into Visual Studio Code. And I'll create a new PowerShell session. And I'll import the pure PowerShell module one more time. And now I need to set a whole bunch of variables purely because I need to go into the server to offline that volume. So I've got my target VM, the disk that I'm going to offline, the source volume that I took the snapshot of, the target volume that I'm going to overwrite, the protection group, and then the flash array IP.
And guys, obviously you can go ahead and automate a lot of those things and create self-sustaining code that will help you out doing those things in the future whenever you need them to, without wasting any time.
Yes, this is 100%. You can write your own PowerShell functions for this, just to drop in the variables when you run it. So you don't need to step through what I'm about to do here. It'll be pretty quick when you run this. Obviously, as demo purposes, we're going to go through each step so I can show you exactly what this is doing.
Perfect.
So again, I'm going to connect into my flash array because I can't type in demos. I'm going to use a credential, and we're connected in. Okay, so I need to create a PowerShell session on the target VM. And now I need to offline that target volume with set disk is offline true. Confirm that it's offline. And we can see there, disk 2 is offline. Okay, we are good to go and overwrite. So I need to retrieve the most recent snapshot, and I do that with get PFA protection group snapshots, my flash array, the protection group, and then I'm just sorting by when the snapshots were created, and I'm grabbing the first one. Hit execute, and we can confirm 267. If we jump into the web GUI, yep, 267 is the one that we want. Okay, now we can overwrite that volume. So just using this command, new PFA volume, on our flash array, our target volume, the one we're going to overwrite, and the source is our most recent snapshot name and the source volume. We can confirm that by jumping in here, clicking on that, and then we've got the volumes in there. So 3, 2, 1, and we're done. Pretty instant, very quick. So a couple more things to do. We just need to online the volume, confirm that volume's online. And then if we want to, we can actually check the data. And what we're looking for is our MDF file for our database. And there it is. It's mounted as the F drive under SQL Data 1. We have that available to us. So we've overwritten. We jump back into SQL Server. And we can attach our database. So we use the create database statement with the for attach keyword. And we're going to attach this as AdventureWorks 2019 reattach, pointing to both our data file and our log file. And we're good. If we confirm, we should have our database attached there, 2019 reattached. And if we refresh the databases in Object Explorer, we have our database there. Okay, so that is a lot faster, say that this was terabytes, petabytes of running through a full diff transactional log restores. We've got that database back pretty instantly. We can now go ahead and fix the corrupt table in our database. And okay, we can go.
Say, looking at this process and comparing it to what I used to do with the DBAs that I used to work with when I used to manage backup systems for enterprises, the amount of time and effort it took us to restore a full database, right? It was even with the biggest, baddest backup systems, that was extremely long and exhausting process. Comparing to this, come on, this looks like a walk in the park.
Yes, instead of having to, you're waiting then, you're waiting for that full restore to restore, and you're pushing your recovery time objectives to the limit. Nope, it's instant. You've got the data there. And what we need to do now is just go ahead and fix that corrupted table. So the way to do this, I mean, we could work out the rows on in the table that were on the corrupted page, but in a production situation, I know I can get that data back from my other database. So I'm going to go and truncate that table. And as ever, things with SQL Server aren't always a walk in the park. This is a relational database. It has relations to the different tables and tables referencing it. So we can't truncate it because of these foreign key constraints. So what we need to do is, like a DBA, we could script out our foreign key constraints. We got 6 of them. And I'm going to go nuclear here. Remember, database is corrupt. I need to get my data back. So I'm going to get rid of them. I'm just going to script them out. Grab these and get rid of them. Okay, now let's try retruncating that table. And this time, good. What we've basically done is grabbed all the data pages for that table and thrown them away. That includes the corrupted page. So now we can go ahead and insert the data from our reattached database. So into our table, from our attached database with our select statement. We hit execute. We've got our data back. And now we can confirm that the data is there. And remember, this is the SQL statement that originally alerted us to the corruption in the database. And this time, our data is coming back clean. We don't have any corruption there. But we still have a little bit more work to do. We need to get those foreign key constraints back. Now, like most DBAs, I have a little DBA database or an admin database or something there where I have a load of maintenance scripts and store procedures, things like DDL statements that can get me my create foreign key statements back. And this is another advantage of having that attached database. I can use that to regenerate my foreign key constraints. Hit execute there. I've got them all there. Let's add them back in. Confirm. They're all back. We've got the 6 foreign keys referencing that table back. And so the final thing to do, just for peace of mind, because we can select from the table, but let's run a check DB just to make sure that that corruption is gone on that database. And hopefully we're all good.
Wow,
so,
Andrew, that's amazing. And obviously, guys, this is us showing a step-by-step and pausing at every step to explain it. Obviously, if you guys automate this process, you can have your database up and running after a severe corruption within less than a minute. This is nuts.
The actual longest period of this would be sorting out the foreign key constraints and getting them back, which we'd have to do anyway if we were doing a normal appointment. We had the database back pretty much instantly, attached back in, and then we could go through all the work to get that data back in, checking foreign keys and things like that.
And again, guys, you don't need to rely on anyone else in order to do those things. You don't need to open a ticket or talk to the help desk guy or the backup guy or the sysadmin or whoever it may be to provide you some resources and to give you the stuff you need.
Yep.
Just go ahead and do it yourself. This is the power of self-service. This is the power of automation. Use it.
So let's jump back quickly into the slides because I want to talk about now is do the point in time recovery with snapshots. So the example we just saw there was a crash consistent snapshot. We took a snapshot of our protection group that had our data and log files in it, attached that to the database. But what happens if we have the snapshot, but it was taken hours ago? So maybe that data had been updated and we need to get that data back, but the snapshot is way out of date. Well, with our Pure Storage Management Studio plugin, we can take application consistent snapshots of our databases. Now, this allows for a point in time recovery. We can attach the database, but bring it up in restoring mode and then restore additional transaction log backups over the top of it, restoring that database to a specified point in time. Now, that does require querying the target database because it goes off to the external VSS provider to stun the volumes that the database is on. So you need to be a little bit aware of how your applications are going to react when you take that snapshot. But we get that added bonus of application consistent snapshots that we can do that point in time recovery. And we could do this all through Management Studio. We have a plugin for it. We have a GUI for it, but you could also script the PowerShell out and grab that for automation purposes.
That's nice. People can use whatever they feel comfortable with. They can use the UI, they can automate stuff. It's really, there's a thing for everyone.
Absolutely. I use the GUI basically to set everything up and take ad hoc snapshots. But if I was scripting this out to put them on a schedule, I'd 100% grab the PowerShell scripts, probably drop them into, say, a SQL Server agent job and have them running on a schedule.
Sounds amazing. So let's see how it works.
100%. Okay, back into Management Studio here, and I'm going to close all of this, and we're going to jump onto a different server and open up some scripts. Okay, so what we've got here is we have a dummy database called test database. There shouldn't be a table in there. Okay, cool. And what we're going to do is we are going to create a table in that test database, import a load of update a load, insert a load of data into that table. Then we're going to take an application consistent snapshot. Then we're going to pretend that someone's come along and run a update statement and messed up all the data in the table. And then we're going to do a point in time recovery to get that data back. So
Sounds
first things first,
interesting.
let's recycle the error log because we can have a look at the database being frozen in the error log. And let's create a table. And this table is just a dummy table with an identity column, one column for our data, and a date created with get date as the default. And then let's insert, say, 1,000 rows. Just some dummy data to have a look at. Nice and quick. And then we can do a select. Here we go. There we are. Load of dummy data in there that we're going to use to update and then return our database to this point in time using an application consistent snapshot. So literally we can just come up here, pure storage, and go to backup. And now when you set this up, you have a configuration, it's called a configuration to set up, where you set a name, the database you want to back up, the computer that it's on, the flash array that the volumes are coming from. We can even have a remote flash array if we want to replicate our snapshot off, say for DR purposes. The volume types, these are vvols, but we also support RDMs and physical volumes. And then metadata location and a backup type of full. We also do copy-only backups as well. We can also view PowerShell script, nice and simple, where we could invoke PFA backup job on our config name. So if you want to script this out, we can 100% do that. But let's go ahead and let's just back up that database.
In the meantime, we have a question from the audience on the Q&A. And Aviad is asking, does this solution work with SQL always-on availability groups cluster?
Yes, you can 100% snapshot the primary 100%, not so much the secondary if it's in read-only mode. But if it's crash consistent, there's no impact on your primary server whatsoever, yes, you can take the snapshots.
So hope that answers your question. So Andrew, back to the demo. What are we seeing?
There we go. We've got our backup successfully completed for our database. So we can come out of here. Oh. And let's have a look at that snapshot in the error log. Here we go. So we come here and we can see IO is frozen on our test database, and then IO resumed. And that was 110 milliseconds. So yes, okay, probably about 100 more milliseconds than I'd like, if I'm honest. You need to be aware of that when you're taking these, that your application can handle that. But we have our snapshot. And if we come onto the array itself, go to protection groups. And click on here. Here is our snapshot take this morning. And instead of just a numerical digit taken, we can see this is taken via VSS by the prefix here. So we have our snapshot taken. There we go. We have our volumes in there as well. So now let's say someone comes along and updates all the rows in that table. They run an update statement without a where clause. They come in here and say set column A to B, 128 length. There we go. And we have a look at this now. The data has been updated across the entire table, and this is incorrect. We need to get our data back to the original state that it was in. So we can use our application consistent snapshot to bring that database back into restoring mode. And then if we had any additional transaction log backups, we could restore over them, rolling this database to a point in time just before this update statement was run. So if we jump into the plugin again and we go to backup history, we can then select our backup and click restore. Click no recovery mode because we want to be able to restore more transactional backups on the top of this, and hit restore. And so this is going out, grabbing the snapshot. It's going to offline the volume on that target server, overwrite that volume with the snapshot, attach the database into SQL Server itself, but bring it up in no recovery mode, so restoring, so that we can restore additional backups over it. And that's already completed for me, nice and quick. So if we have a look at the restore in the error log, we can see VSS provider doing a whole bunch of stuff, but we can see that it's starting up our database. Now it's marked as restoring, so it doesn't allow recovery to be run, but restore database completed, and it's very quick because yes, this is a dummy database with just one table in, but it would be pretty much instant no matter how big that database is, purely because we're using a snapshot to recover it. And if we do a refresh here now, we can see the database is in restoring mode, which allows us to restore additional transaction log backups over the top of this database, rolling it to a point in time where that just before that update statement was run. Now, I don't have any more transaction log backups, I'm afraid. So what I'm going to do is recover that database with restore database, test database with recovery. There we go. Excellent stuff. And then just to confirm, let's have a look. We have our data back. So by using the Pure Management Studio plugin, we can take application consistent snapshots of our databases and then use those to, oh, let's do a refresh there. Bring the database up in restoring mode, and then we can restore additional transaction log backups on top of it so we can get our data back. So we don't even have to, I use Management Studio every day, all day when I was working with SQL Server. I don't even have to leave Management Studio to take these backups and perform those restores. I can do it all here through the Management Studio plugin.
So guys, this goes back to what we said. We want you to be independent. We don't need you to go out of your comfort zone, to go out and maybe rely on other people. Be self-sufficient. Use the tools that fit your style of work. This is what we want to achieve, full independence for our DBAs.
One really nice thing about this plugin as well, okay, say we didn't want to overwrite the test database there, we wanted to restore it to a different server. We could jump on here, go to the backup history. Now, instead of clicking mount, restore, sorry, I could click mount. And I would pick my computer. And let's go for 01. And what it's doing is going off and looking at the available drives on that server, and it'll give me an option of how I want to mount this database. So I don't even have to have the volume there. This will create the volume for me off the array and overwrite with my snapshot. So I've got E and F on that server, so I'm going to go with G. Select my VM. It's going to go off to vCenter to get its persistent ID. This is my lab, so this one. And then I can just click mount. And that's going to go off and create the G drive on my server, overwrite that volume with my snapshot, and then I can go ahead and, like we did in the first demo, grab my database data and log files and attach my database. There we go. Nice and quick. Okay. So what I can do now is come in here, go attach my database, add, and we've got a G drive here. And if we have a look, there's my test database MDF. Click OK. Need to do a little bit of an update here because it always seems to think the data and log files are in the same location. There we go. OK, and click OK. And there it is. Come back in. Where's my table? Do a select from my database. And there's our data.
That really, really is simplistic.
Nice and easy to use. I know I've got my snapshots, so I can see my backup history. Click, click, there's my database.
And
nice
guys,
and
also you can think about tons of opportunities, tons of things you can do with those capabilities, either to take data and offload it somewhere else. That might be a use case. Take data and provide maybe the BI people or other business units in your organization real life data from the production environments with the snap of the wrist, right? They don't need to wait to get their copies of the data. They don't need to work on obsolete data. And to be honest, nowadays, and our old data is old, right? So we can automate those processes and really enhance the data-driven processes within our organizations using those tools.
100%, absolutely. The benefits of snapshots, I think every DBA, especially running on Pure, should be embracing, because as we've shown, in certain situations, they're so much more advantageous to use than the traditional full diff, transaction log restores. If you're running SQL Server on Pure Storage, please do go ahead and check out the Snapshot technology because it could be really advantageous for you in your environment.
And if you are not using Pure Storage, give us a call. We'll help you get there.
Okay, so we're coming on to the end of the session now. We've got a few minutes left. What I want to talk about is an extra benefit of using snapshots that came with the new version of SQL Server, which is 2022. And that is the ability to seed secondary nodes of availability groups with an application consistent snapshot. Now, I've got an example availability group here. We've got a 5-node AG with 1 primary and 4 secondaries. When we set this up, we can seed those secondaries in one of 2 ways. We could do it manually with a full backup restore and then a transaction log and add the databases in on each node, or we could use the built-in automatic seeding function within SQL Server itself. Now, again, this can take some time if A, we've got a lot of databases, or B, if those databases are fairly large. So by using the new native T-SQL snapshot backups, we can bring that time that it takes you to set up your high availability solution down considerably. Now, I do like the automatic seeding feature in SQL. I've used it quite extensively. There does seem to be a sweet spot with it where I think it's about 5 databases at a time. Otherwise, they just drop out and you need to monitor them and then re-add them in and things like that. And manual full backup and restore, yep, works fine. But it's, yeah, the word manual in there, as in, if I have a 5-node AG, I'm gonna have to do it 5 times, script it out. And then again, if these databases are large, I'll be waiting to get those databases into my AG. And I don't really want to be sitting there waiting, watching full backup restores happening. If I can do it instantly, I absolutely am going to. And we can with these new T-SQL snapshot backups. So once again, no messing around. Let's dive straight back into the demos.
That's what I like with you, Andrew. You always go down to the dirty stuff, to the live demos, no presentations. I absolutely love it.
Thanks. I much prefer showing people what we can do than just having them on the slide saying, yes, it definitely works. Don't worry about it. I like to prove out that we can do these things. So if I close this down and I'm bringing another server here, I have these 2 boxes already set up with an AG called AGDR, both nodes, all good. There's no databases on O3, they're in the AG. Cluster is all set up. If we have a look here with my nodes, I'm good to go. So typically what I do in the past is just add that database into the AG and let the automatic seeding work its magic, get that database onto O3 and sync up, no problems. But again, if that database is large, can take some time. So let's use T-SQL native snapshot backups to get that database into the AG and synced up on its secondary. So I'm going to jump into Visual Studio Code. I'm going to do everything in Visual Studio Code for this. And let's come here. There we go. So to do this, I'm going to use our Pure Storage PowerShell SDK module and a module called DBA Tools. Now, this was written by Chrissy Lemaire many years ago for migrating SQL instances, like all the databases, logs, users, things like that, from one instance to another. But it has since grown since then. It's a massive community effort. There's hundreds of contributors, and there's about 500 different commands that you can use when working with SQL Server. So if you're working with SQL Server and you haven't checked DBA Tools out, I highly recommend you do so. So I'm going to import that module, and I'm going to set all my variables. So same as before, I'm going to set my source SQL instance and my target SQL instance. But the disk that I'm going to overwrite, the source volume that I'm going to take the snapshot of, and my target volume that I'm going to overwrite with my snapshot. The flash array IP and the protection group, my volumes are in. So let's set all those. And now let's connect into those SQL instances. So I'm going to use DBA Tools command called connect DBA instance to open a connection up to each one. There we go. Looks good. Let's confirm. 1, 2. Yep, we're all good. We're all connected in. Okay. Let's cycle the error logs on both of those, just so we can have a look at what's going on in the background. And now we're going to take our snapshot. So first thing to do is create a session on the target VM so I can offline the volume. Again, you wouldn't usually do this in a production environment because the credentials are stored in a .cred file, but I can't type in demo, so I'm just importing them in so I can connect into my flash array. There we go. Okay, and now we are ready to take our snapshot. Now, with the previous application consistent snapshot, we used the plugin which went off to talk to an external VSS provider that's quiesced our database for us. We don't need to do that in SQL 2022 anymore. What we can do is use this new syntax called suspend for snapshot backup on. And this is what quiesces our database. So we can hit that in a SQL query. And now we can take our snapshot. So we're using the same command as we did in the crash consistent snapshot, but this turns it into an application consistent snapshot because the database is quiesced. So it's just new PFA protection group snapshot on our flash array and protection group name. I'm just doing some sort objects at the back.
And again, Andrew, maybe just to recap again for people who might not know, or maybe late joiners, what is the huge differentiation between crash consistent and application consistent while using SQL?
So crash consistent is just a snapshot of the volume, say, hosting our data and logs at a point in time. Application consistent snapshots differ in the fact that the database needs to be stunned, IO frozen before the snapshot is taken, then IO released. And the advantage of that is we can bring the database up in restoring mode to be able to do a point in time recovery. Or in this instance, bring the database up in restoring mode so that it can be used to add into an availability group.
Perfect. So let's continue, please.
No problem. We've taken our snapshot. So now what we need to do is take a backup of that database. And we're just doing a new syntax keyword called metadata only. And when we take this, this resumes IO on our database. So let's have a look at, jump onto the SQL instance. And if we come here and let's have a look at the error log. And we come up. We can see that IO is frozen and then IO is resumed. Now, that took a long time purely for the fact that we were talking whilst we were taking it. But if you were doing this, you'd say bang, 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 take your suspend IO, take your snapshot, take your metadata backup. Very, very quick, no external things. It's all done within SQL and on the pure flash array. Pure flash array snapshot is instant. So be very quick coming to bringing down that time that database is quiesced for. And if we look on the array as well, if we come in here, we can see we have our snapshot here as well. So we have our snapshot. Let's go ahead and let's get that database into our availability group. So let's offline that target volume on our VM. There we go. And let's confirm that volume's offline. I'll clear this up, make it a little bit nicer to look at. There we go. And our volume is offline. The reason there are 5 volumes there and not just the 3 that are on the server is the server is in a cluster, and get disk, when a server is in a cluster for our availability group, will return all the volumes on each of the nodes in the cluster. So now we can grab our snapshot. So get PFA protection group snapshots, and then we do our sort object. First one. Confirm. 76, excellent. And now we can overwrite that volume on the target server with new PFA volume, target volume, the snapshot, and the source volume, with the keyword obviously of overwrite. Hit execute, boom, instant. So now we can online the target volume, confirm, and then we can check that the database files are there in SQL data, and there we go, and we've got them there and there. Okay, so we've overwritten the volume. We've got a little bit more work to do to get this into an availability group. The first thing we need to do is take a transaction log backup of the database on the primary server. So we just take a nice quick backup. And now what I'm going to do, which you wouldn't have to do in a production environment. In a production environment, both servers would be able to point at, say, a shared location where the backups would be. I don't have this in my lab, unfortunately. So what I'm going to do is copy that metadata backup and the transaction log backup to my target server. And now I can restore my database onto my target server, that ZAP SQL 03, from my metadata only backup that we took at the start. So here we go, using the keyword metadata only. Hit execute. Very quick. And then restoring our transaction log backup. Excellent. So if we come into the SQL instance here and do a refresh, I close this, we have our database up in restoring mode, so we can add it into the availability group. So one more thing to do, just say alter availability group name, add our database. There we go. And we can confirm. And then I can close my connections. But if we do a refresh here now, we have our database synchronized in our availability group. We can confirm that if we come in and do show dashboard. There we go. We can see that our database is completely synced in our availability group. We have set up our secondary node and added our database in, all using the new SQL native the native T-SQL snapshot backups to get however big our database is into our AG.
So definitely this is a very, very powerful capability. This takes best of both worlds. The snapshotting capabilities that we have with Pure Storage, the new capabilities that SQL has. Guys, you can go ahead and really enhance what you guys can provide to your organization with those types of technologies. This is really a game changer. We've said it a few times during this session, but I really think this is something special that we have here. Andrew, any last thing you want to talk about before we close this up?
So the only thing I want to mention is that, as I said, if you are running SQL Server on Pure Storage, please do check out that snapshot technology. It can be really advantageous for you in certain situations, getting your data back. And then if you're running SQL Server 2022 set of availability groups, 100% be using the new native T-SQL snapshot backups to seed your secondaries. It'll save you a lot of time and effort. And if I don't have to sit there watching full backup restores whilst waiting to set things up, 100% going to take that opportunity.